Blibli.com is a large nationwide Indonesian e-commerce company. It operates a buyer-to-consumer model, operating multiple warehouses across the archipelago and serving a wide array of customers. This also means that they have a lot of database to base their improvements on, although sifting through all this information is painstaking. How do we incorporate machine learning into this? We are joined by two speakers from Blibli.com, Welly Dwi Putra, the Assistant Vice President of Data Science, and Siauw Kian, Senior Vice President of Development.
Yeah, hi guys. So let's start. Okay. So thank you guys for joining. Today we'd like to talk about leveraging e-commerce data with machine learning. Before that, let me introduce myself. My name is Welly Putra. I'm from data science team at Blibli.com. A little bit background about myself. So I joined Blibli since 2013. I started as a software engineer back then. And then maybe after 2 years since I joined, I got offered to move from the developer to data team. So I accepted that. And up until now, I'm in the data team, especially in the data science team. And also, we also have Kian here. He's SVP of development in Blibli.com, and he also supervises data team in the technology. So our agenda today is consists of these three topics. The first one is building the right data structure. The second one, understanding customers through data analysis. And the third one is leveraging e-commerce data with machine learning. So I think why we start at the data structure. I think that if you guys like want to build a startup company, you have to understand like a little bit end to end, right? So I think it's best to start from the data structure, knowing where to get the data, where to collect data, down to the data analysis and down to the machine learning. So you can get the overview of what data team does. Okay, let's start for the first topic, building the right data structure. So before that, let's discuss first, like what is the difference between conventional retail versus e-commerce in terms of the data that we have. So in the conventional retail, we might have all data, transaction data, the same as what e-commerce has, right? We know that this product purchased at this price point, at this quantity, at this time. So we know all of that. But what about customer data? Do we know who are our customers in the conventional retail? Maybe because like if the customers apply a membership, we can know like their gender or their age, their name, their email address, their phone number, and all of that. But what if the customers didn't apply a membership? We wouldn't know like who are our customers, right? But for e-commerce itself, we should know because e-commerce, we have to apply a membership in order to purchase from the e-commerce, right? So e-commerce has richer data in terms of customer data. And also, how about the traffic data? We could count the number of visitors in the conventional retail by maybe hiring some people to count it manually, or maybe hire some people to check the CCTV and count manually one by one how many visitors in this peak hour or how many visitors in this non-peak hour. So we can get data from there, but it takes a lot of effort. But compared to the e-commerce, we can build the tracking system by ourselves, and we can also use what is already available at the market. For example, Google Analytics or maybe Firebase. We can use that, and then we can gather data easily. We can know like how many visitors in our website, like what are the demographics, and which page do they bounce or do they churn. So we can know all of that. That's why e-commerce is in a better position in terms of having more data. But e-commerce will face like what I've said, like big data problem, because it has a fee, right? The volume is huge. If we store all of our data into the traditional database, it will not fit. We need a structure that support a big data, and then a velocity. the business of e-commerce is growing exponentially. That's why we need a data structure that cope with that exponential growth. And then the variety. Think of product information. For the product information itself, for example, the product name and the product description, it is the text data, right? And also the product photo. Product photo is the image data, and the product price, the merchant location, merchant ID, and all of that things is the tabular data. So for the product information itself, it contains a lot of variety of data. And then the veracity. Veracity is a noise or like anomaly. Because we are in the internet company, we couldn't validate like this is the real users or this is the bot, or maybe there are some users that are very anomaly in terms of the traffic, in terms of the search query. So the veracity is very huge also. So that's why e-commerce has this 4V, and we can categorize the e-commerce has a big data. And then big data needs a right data structure. What is the right data structure? So in our understanding, there are three parts that we can consider this is the right data structure for us. The first one is the scalability. We want our data structure to be scalable, so it could hold a lot of data, and also it should be reliable. We want it to be 24/7 uptime, and we don't want it to be slow, right? So for example, if we want to analyze data, we don't want like we need to wait 1 or 2 hours just to query some data and then come back again and look at, oh no, I'm missing something. Then we need to add the filter and we need to wait again for 1 or 2 hours. That's so much wasting time. So we need our data sector to be reliable for us. And the third one, it should be less maintenance. So we don't want to waste our time in terms of like maintenance our data system. So we want to be focused more on the data itself. We want to get insights from data. We want to build machine learning on top of the data without worrying too much about the system, the architecture, or the workflow from the data. That is why we are right now we are using the Google Cloud Platform, which enable us to just really focus more to the data. So if maybe you have known or maybe you haven't known, Blibli.com is the adopting the microservices approach. That is why maybe its service can store the data into the Postgre, into the tabular data, or maybe some services could store data into the document-based database like MongoDB, or maybe in the file storage. And we also have like the third party data, right? For example, like Google Analytics or Firebase that I have mentioned. So we want to gather and collect all of that data to our data lake, which is the Google Cloud Storage. After that, we will build the data warehouse and data mart from that in the BigQuery. After the data is already in a BigQuery, we could do a lot of analysis. We could build machine learning in from that data, and then the result could be shown in the dashboard, or could be we could use the Elasticsearch as the serving layer, or maybe serve our model as an API in the AI platform itself. So this is a simplified version of our data structure. It actually has a lot of components, but I tried to put just important components here. Okay, moving on to the data analysis. So we have a lot of data, right? Like the customer data, even like the warehouse data itself, logistic data, the merchant data. So for this session, I want us to just maybe narrow down our context into just customer data, because if we talk about a lot of data, we will not have much time for that. So, what are our customer data? Right? We have the demographic data of the customers. We have like the gender of the customer, the age of the customers. We also have the device preference of the customers. Is the customer using Android app, or is it using iOS app, or is it using Windows web Windows desktop or is it using Mac OS. So we can know from the tracker service that we have, we can know the device preferences of the customers, and we also know the geolocation of the customers. For example, if is it Indonesia, is it in the Java island or is it outside Java? And also we have the purchase history. The purchase history, we could get like the what are the customers preferences, right? For example, if the customers purchase a handphone like a laptop, then we know that these customers is the gadget and electronic customers. If the customers purchase like groceries, then we can categorize that as the groceries customer. So from the purchase history, we could get a lot of data, and we could also segment our customers based on purchase history also. In this example, I'm using a RFM model, which is commonly used in the e-commerce. So RFM means recency, frequency, monetary. So we segment customers based on how recent have they purchased from us, what are their frequencies, and how many values or how many monetary that they bring to us, so that we can take action based on that. For example, if the customers has a high frequency and high monetary but low in terms of recency, we could do the win back campaign, right, to reactivate the customers, because these customers before he or she generate high value and high frequency, right? We don't want to lose that type of customer, so that's why we launch a campaign to win back those customers. And other segmentation, we could separate like good or bad customers. What do we mean by good and bad customer? We can think of like bad customer as the customers that are violating our terms and conditions. For example, if we have like a promotion and we already said that, oh, this promotion, one customer only can get one voucher or only can use one voucher code, but these customers are creating multiple accounts, or maybe they are using bots to abuse our promotion. That's what we call like bad customers, because they are abusing our TNC. And to catch that bad customers, we have to really have like a good fraud detection system, for example, so that we can like distribute all of our vouchers fairly and equally to the our customers, especially for the good customers. Okay, this is the example of maybe one customer profile. Maybe the age span of this customer is 25 to 30. Gender is male. Location maybe in Jakarta. Device is Android app. The last active is 1 week. Most active time is after office hour. 3 last purchases: shoes, snacks, and video games. Recency is low, frequency high, monetary high, and fraud indicator is low. Based on that, if we as a marketing user, we can know like what action can we give to this customer. We can like I have mentioned before, we can win back this customer. How to do it? By giving them discount voucher. And how to do it? Because we see that the device is the Android app, we can push notification to the Android app. And at what time? We can look at here. Most active time is after office hour. Then we know that this customer maybe in the way of going home, he check his phone often. So we can push the notif at the time. And what content do we give them? Like so. From this data, we can know like we can give them like maybe related to purchase history. We can give them like shoes discount or video games discount, or maybe based on demographic, like male in the age 25 or 30. Maybe he is the gadget customer, so we can give them the gadget promotion, something like that. So this action we can think of like what is the best action to be given to the customers. But to do that, it's very manual, right? Because we have to look at the data one by one. That is why we can build like the machine learning to do this type of thing. and then it can be automated and it can be scalable up to like million of customers. So that's why we have to leverage our data, our e-commerce data with machine learning. So that's what I mentioned, that it could be scalable and could be automated. Okay, leveraging e-commerce data with machine learning. So like I mentioned before, the more data and the more parameters we have, we could have like the better enablement of the machine learning, because machine learning, as we know, we should have like a lot of data in order for the machine learning to perform better. And then we can do like the product recommendations or the fraud detection. I will explain one by one. So for example, the product recommendation, the machine learning can learn from the customer data, the customer view, product view, or customer search behavior, and the machine learning can know like, or maybe this guy is married with 2 kids, or maybe he is a private employee and passionate in music, and then the machine will output like this product the customer might like. For example, in this example, it shows like guitar and motorcycle. And also on the same case, if the machine can categorize that she is a single and entrepreneur and food and fashion lover, she will be given like the fashion items or maybe makeup items. But the machine learning by itself, we only give them data and it learn the behavior of the customer, so it could give the best product recommendation. And also the lifetime value prediction. So imagine if we want to buy like products, for example, we want to buy a phone, right? Do we choose like the cheapest phone in the market, or do we choose the affordable phone but bring us more value than the cheapest one? So that's the premise. So that's why we need to create the lifetime value prediction. If we look at our customer data, for example, if we have two segments of the customers, the first one is the 500 customers with the acquisition cost of $10 versus 500 customers at $2,000 each acquisition cost. So which customers do we choose? If we only have like acquisition cost data, we will think that it's better to have this cheaper acquisition cost customers. But if we given the future value of the customers, for in this case, the future value of the customer with $10 acquisition cost, $100 versus the second one, like the lifetime value of the customers if is $500, we will choose the second one if we can afford $20 acquisition cost, right? Because it brings us a lot more value than the $10 one. So that's why we need to build the lifetime value prediction. Lifetime value prediction model can consist, we can look at customer data like this one. We can look at the registration date. We can look at the frequency. We can look at the recency of the customers. We can look at many other data, like maybe 2 out of 5 orders of that customer are purchased without using promotion. So many data that we can use from the customers to be fit to the LTV model. And then the output of the LTV model, we can project the revenue of the customer, or maybe the order, or maybe the lifetime value. Think of this like for example, if we want to invest in a company, right? We have to know like what is the current revenue and what is the projected revenue, or what is the projected margin of the company. So that is why we take each customers like the company. We want to invest in the customers itself, and we want to invest in the good and high value customers. Okay, the third use case is the fraud ring detection. Like I mentioned before, if we have like promotion, there may be some users that are abusing our TNC. We have to create the fraud ring detection to detect the fraudster that has created multiple account to abuse our promo. So in our cases, we can use the graph to map if this user has the same phone number with that user, we can group that together, and also we can run machine learning model on top of that graph database. So there's also a use case for this. And also the fourth one, we can do the automation of the product upload. So as you may know, our customers is not just the end customers buying from us, but also the sellers, right? Sellers want to upload their product easily. That's why we need to care about those customers. So we want to make their life easier. So what our plan is that we have to, so the sellers could just input the product name, or maybe just input the product name, product description, and the image, and we fill all of the other information. For example, in this slide, the Apple iPhone 11, the category prediction model could predict that it is a handphone, and then it will give the to the other machine learning model. In this case, is the attribute extractor for handphone and tablet, and that attribute extractor could extract the attribute of that product. For example, the RAM maybe 64 GB gray, and maybe it could identify what are the missing attributes for the sellers to fill again. So it benefit both the customer and it benefit the sellers to provide more clarity, and also the customers could get the better clarity and complete information of the product, and it will trigger them to buy that product if the product has complete information. Okay, so the next topic is the important steps in machine learning project. So there are a lot of steps, but I've tried to simplify it again into 4 steps. This is the beginning steps, because what I don't cover in this session is that the monitoring part, the deployment part, like the iteration of doing testing and so on. So what I want to discuss today in this session is this just four steps. The first step is framing the problem. Second step is defining objective, exploring data, and also up to design a solution or model. But I think this fourth step is the one that are really important, because the deployment part, or maybe the modeling part, I think nowadays it could be automated. We have seen a lot of services that give us feature that can automatic machine learning that can, if we just put the data, and the service will kind of figure out which model will work best for that data. So and then we can deploy it just easy as just one click, and then it could set up the monitoring for that. So all of that is already covered by the platform that we choose. That is why I'm focusing on these 4 steps. The first steps is the framing problem framing. So we could, where are the ideas come from, right? The ideas could come from the complaint of the customers. Like for example, if we have the complaint of customers that said that have something like this: I visited your site, but I didn't find any interesting product there. So based on that, it's still quite abstract. Like what is the problem? So we need to narrow down the problem. But how can we do it? By doing data analysis. So there we could just think of many possible assumption of what the possible problems is or are. So like for example, I'm thinking that there may be the 3 problems here. Is it because of our product selection? Maybe our product selection is so little so that it couldn't cover the customer need, or maybe we already have the products but the customer didn't see it. Maybe because the customers only browsing the homepage he scroll down up until end of the page, and he doesn't, or he or she didn't find any interesting products there, and then he left. Or maybe he stopped after he searched multiple keywords, and then he or she left. So there's multiple possibilities. And also maybe he or she is looking for rare products, right? Because the product is so rare that it is not available at anywhere. So we have to narrow down the problem here into, like, maybe after we do some analysis, we could narrow down and we think that, oh, maybe this second one is the problem. Like, if we already have the product, we check the data and we compare it in the, like, the customer preferences of the customer search, and we know that this customer is maybe dropped at the homepage. So based on our data analysis, we could narrow down the problem into this problem statement. Like, okay, customers couldn't find products or content that are relevant to them, especially in our homepage. Like, right? But the problem will come, what we need to define the objective for this problem, because we could not just say, okay, we will give customers the relevant product, but we need to define, like, how can we set that this is relevant versus not relevant. So that's why we need to be to have the objective that should be measurable. It must be measurable. So the objective could be increase click-through rate. If we have, if the customer drop at homepage, right, we should have some maybe product recommendation, or maybe like a banner or promotion that are relevant to them, so they will click that. So we could, like, measure the click-through rate of that product or that promo banner. Also, maybe we can look at the conversion rate also, and also, like, the bounce rate. Bounce rate is the customers that are coming to our website but only at certain page one time and then drop off. Or maybe increase the session duration. Session duration is important maybe in the company that are not selling the product but selling the content, because we want viewers or readers to stay at our site in the long time, right? Maybe for example, news company, or maybe like social media, we want people to stay at our site in the long time. That's why this metric might be more relevant to those types of companies. So the objectives here, we should have, like, the business context to determine which objective is the right one for us. And we need to have the exact number, or if we want to increase click-through rate, by what percentage or to what percentage. That is why we could have, like, the goal and the target to achieve. And the next one is data exploration. So after we know, like, oh, this is our problem, this is the objective, we can look at the data again and to see what data can we use. For example, the product recommendation one, we could use the transaction order data, we could use the product views data, we could use the search data, customer data, and many more data that we can combine. But the problem is, maybe for early startup or early company, they haven't collected maybe the product views data, because maybe they haven't implemented the trackers yet, so they are missing this type of data. So we can start by using our data that already available, and moving on, we can add on and add more data or to the model. And the next one is that do we have enough data? Because some model might need a lot of data. Take example like the deep learning model. It will need more data than the machine learning one. And then how's the data quality? We need to check it also to audit our data, so that we don't get, like, out by after we do modeling and then we realize that the data is so bad. It's already too late, because we already spent time, like, design the model of the bad data. So we need to really auditing our data first. Like, is there any null or incomplete data, or is data format consistent? For example, if we have the gender data, is it the text like male, female, or 0, 1 encoding? We need to make sure that all data is in the same format, and then we can maybe if it is a male female text data, we can encode it later. Are there any outliers? For example, if we want to predict lifetime value, right? If there is an outlier that maybe this customer purchased like million, like 100 millions of value, or maybe this customer is having thousands of orders compared maybe just average customers has it is which is maybe like 10 or 12 like or something like that. So these outliers, do we want to include it to our model or do we want to exclude it? So is the data make any sense after like we doing like we compute the statistic of the data, like we look at the average, the median, like the top, maybe we look at the top products, the top customers. We look after we look at data, we can know like is the data makes sense to us. Like the data will not make sense if there is there are outliers out there. But if the data is already makes any sense, then we can move forward to designing a solution. So in the next step, we have the designing the solution or model. This image actually I got it from the Google. So a Google machine learning course. So it said that the machine learning steps is actually it's same like the software engineering. Like we have the version 1 and we have the MVP product, and we move to the version 1, version 2, version 3, and so on. So it is continuous improvement. But what is the good heuristic mean? So I will give an example in the next slide. For example, if we want to build the product recommendation model, right? So the first initial system is that maybe right now the product recommendation at homepage is curated by the business user preferences. So if the business user maybe have in mind that this type of handphone is selling, then he or she will put the handphone to the homepage. So the initial system is the curated by business users preference. But what is the good heuristic that could bring a lot better value than the initial system, and maybe could be automated or maybe scalable? So we could like just count top products bought, or maybe we could a little bit personalize like the top products bought within the customer's area. So if I'm from Jakarta and I browse Blibli, I might be given the product bus within the Jakarta area. And maybe if someone is from like Medan, and then they see the product might be different from me because the top products bought within the Medan's area are different from the Jakarta. So it's the good heuristic model. And also we could like use trending products, the same like Twitter, it solves like trending topics, and maybe like Instagram, it will show the trending posts or trending feeds to us to look. So it is a good heuristic. But can we improve that by using the machine learning? For some cases it could, but for some cases it couldn't. So not all of the problems need to be solved by machine learning, because if we just have like good heuristic model and we think that is already enough, then we can stop it here, right? Because we don't want to spend a lot of time researching just to increase like a little percentage of maybe CTR, because maybe we can have like area that we haven't touched yet, and we could bring a lot more value than the one that if we just applying machine learning to the one that already has a good heuristic. But for this example, we have seen it also in our experience that this good heuristic model could be beaten by the machine learning. After we applied machine learning, like for example, the first one is similar product or market basket analysis, we could see the improvement of CTR and conversion rate. And we move on, we move to improve this model. we use the collaborative filtering in the next version, and in the next version we make the personalized model out of that. So each customers could get a different personalized content that so that it will increase. So the customers will feel that they are looking at the relevant products in their homepage. So in this slide, I want to say it again that the machine learning model could improve a lot in the version 1, like 2 times, but along the way, maybe the improvement is not so much anymore. But it's better to start at the good heuristic model as our benchmark. So when we design the machine learning model, we need to beat that good heuristic model. Okay, I think this is the last slide of my presentation. So I want to kind of challenge you guys if you want to write a comment to discuss of all of these issues. How can we frame a problem if we see that this issue is customers complaint issue, or maybe we get it from data that show that maybe our delivery is slow, and we need to frame a problem out of these issues. And what are the good heuristic model that what are the objectives first? What are the heuristic model that we could develop? And what are the plan of using machine learning? Is it we are using the supervised or unsupervised, or maybe later we will use the deep learning with this type of features. So if you want to discuss, you could leave a comment there. Maybe we could discuss it together, or maybe if you have any question, you can raise it also in the comment. But I will give one example here. Maybe I will choose the first one, like the customer couldn't buy our products because those products are out of stocks. So the problem framing, after we narrow down, it could be that the products maybe because the business user didn't properly predict the demand, right? So the products will always go out of stocks. So the objective is to reduce the number of out of stock views from the customers. So maybe the first the good heuristic model could be we could just talk like the top 100 or top 1,000 products that the customer bought. So we ensure that top 100 or top 1,000 products are always available, are always are not in the out of stocks. But in the machine learning version 1 or going on, we could do the demand prediction or inventory prediction, or maybe later we could predict in each area how many demand that could happen in those areas. So we can move the products to the area that closer to the customers, which also increase the delivery time. Okay, I think that's all from me. I will look at the question. Okay, the question is, what are some privacy laws in Indonesia? How does Blibli navigate the intersection between ethics and using data effectively? So I'm thinking that as long as we don't use, as long as we don't give the data that the customer input in our place to the third party, or maybe because we have like the PII compliance, like we couldn't give like customer name, customer email address, customer gender, customer phone number, address to other party. We are prevented to do that. But if the data is the customer input the data in our system, we could use that. But it's not like we could use it to give the customers better experience, because we are like the customer focused or customer obsessed company, right? So as long as the customers are feeling better or got advantage from us, I think that's okay. Uh, do we have Pagikan here? Maybe he wants to add something.
Oh, hello, thank you.
Yeah.
So, oh yes, so Welly has provided a great answer for the how we use our customer data. So it's something that we take very very seriously. Actually, tens of millions of customers have entrusted their personal information to us, and in fact, Blibli is one of the first e-commerce companies that received the ISO 27001 certification for the customer security data protection. So that being said, the laws in Indonesia is still pretty in gray area. So there is this electronic information law passed in 2016. It only covers general broad guidelines on what we do, what we can do without any specific steps on the safe harbors. But we pretty much try to use our common sense and get our customers permission before using any of their data for our marketing purpose. We never sell our customers' data to third party. That's something that we closely guard and make sure that it's permission based. Everything that we do is by permission of our customers.
Okay. Thank you, Pagikan, for the answer. So we move on to the next answer. The next question: do we need to have a solid math foundation to excel at machine learning? At some point, yes, but for the early stage, like I mentioned before in the slides, to have an advantage of doing the heuristic or doing the machine learning model, actually it doesn't need like a good, great math skills, because we could just build on top of a common sense. But along the way, after we improve and improve again, then we might need some skills and expertise. For example, product recommendations, right? If we think that the product recommendations are important and generating a very good results, we want to keep improving them. But in order to keep improving the model, we need to be to expert in that area, in that product recommendation area. So the data science team or the developer could just take the expertise in that area. So not just like expertise in all area, but just one area to improve the model. But I think, like I mentioned before, also the service that like Google or Amazon provided is already they already provide like the like automated machine learning and stuff like that. So it make us easier that maybe the one that don't have the math background to be able to use machine learning. And the machine learning that they produce are, I have tried it, quite as good as the one that we manually crafted. But the skill set of the data science not end just there, because like I mentioned before, these four important steps, the machine could not figure out. We could not just say to the machine, "Oh, our delivery time is low. Please create me a solution to beat that, to tackle this issue or this problem." We couldn't do that. But we, as the data scientists, need to figure out what the problem is really are, and then we extract the data from there and we put it to the model, or maybe we put it to the automated machine learning to be able to output the result or the model that we need. So yeah, the answer could be yes and could be no, based on the stage that we are on right now. Okay, the next one is what do you think of a GPT-3? So actually, this session is not discussing like this is the best method or this is the best like library or model. because I think it's based on the data itself, right? We need to try first. Like, for example, maybe we have the data here and we tried using the TensorFlow or using the PyTorch, using the YOLO algorithm and something like that, and it could produce a better accuracy than the other one. Then maybe in the other use cases, we apply the same model that we have in this area to that area, and we see that this model actually lose to the other model. So it really depends on the data itself.
So maybe adding some thoughts on that is just my private view actually. GPT-3, it's something that is just recently shared. It's actually still in a beta step right now by OpenAI. We haven't actually looked into this, but reading into it, it looks it looks promising in terms of the capability that it provides for the language processing. Because I think you guys all know that natural language processing is something that is quite challenging, especially for in in for us who deal with bahasa Indonesia. But we'll see how what kind of capability can be leveraged for several use cases that is specific to e-commerce that we have. Something that we do deal with natural language processing is, for example, getting the feedback from social media comments, the sentiment analysis in there, automating the moderation for product reviews, product discussions. So if we can get some help in terms of technology to deal with that, that's going to be very helpful. So it remains to be seen how we can leverage that.
Okay. Okay. Moving on to the next question. I'm pretty interested in a career in data science. How did Kian and me get into the field? Maybe I will answer it from my perspective first. So actually, like I said, I'm from the software engineering background. Like before I joined this company, I took couples of the coding competition, which is the algorithm competition. So I think that background gives me an advantage because I know like how to design a solution based on the problem statement given in the software engineering area. So the skills took me to where I can just apply this to the data science fields. And then I also after I joined data team, I also like learned it by myself. I took a couple of the data science courses out there. There are a lot of courses in the like, for example, Coursera, Udemy, Udacity, edX. So there are many courses available. You can take it. After that, you need to like really practice, right? So you can practice in the field that you are interested in. For example, if you're interested like in the stock market, like you could just use the stock market data and build your own model. And maybe if your model is pretty good, you can use it yourself, and maybe you can get benefit from that. But if not, then it will be a learning experience from you too. And then maybe you can move on in building a more model based on your interest. Yeah, that's my answer.
Yeah, let me add a little bit to that. I think I have heard that data scientist is classified as a computer scientist who knows statistics better than most other computer scientists, and a statistician who knows programming better than most other statistician. So data science is really in the intersection of that those two fields in the industry. So people can get to data science from either one. Both of us actually came from the computer science part, but there are many others that come from the statistic part also. So it's something that is in the intersection, and I think coming from either field, and we can learn, we can get more knowledge through the many resources available right now to build the other skills that we have. The other thing is that maybe actually back when I was in college many years ago, this data is not something that is even there's no major people are majoring in data, but nowadays there are really few universities offering tracks and study programs related to data. So that's also a great way to get started in the field.
Okay. Yeah, thank you for the answer, Kian.
Sure, really.
Okay, the next question. What are your thoughts on federated learning, and do you think it will help reduce the compliance overhead for tech companies? For this question, maybe you can help answer, Pak Kian.
In fact, I'm not familiar either on this federated learning, so I'll probably have to take a pass on
Yeah.
this and contact offline on to whoever is asking the question.
Okay. Yeah. I think we will take this question offline and we will answer it after this session. The next question is, what are other sources of problem to be framed other than from customer complaint, especially when you just start out your business? So my answer to that is that actually the customer complaints is the only one way to get insights, but actually the insights come from our data. If we have like a good report or good dashboard, good analysis that already in place, we can see that is the data actually in the good, maybe in the good form, on the good run rate, or maybe the sales is slowing down. We could see it clearly from the dashboard, so we can know like, oh, this is the problem, we have to solve this. So I think that's the other way to look at it, other than just from the customer complaints. Is there anything that you want to add?
I suppose our our business stakeholders are also a good source of this opportunity, right? We constantly learn from them what is our difficulties. For example, several that the business case that Welly what he mentioned during the presentation actually originated from our business issues, not necessarily from customers. So how do we identify our most profitable customers? Certainly, customers do not complain about that, but our business team would like to find that. They want to know the information so that we can identify and then make sure that we keep the relationship, good relationship with these most valuable customers that we have, or on the attribute extraction, for example, or the phone product category detection. So all those comes from business problems. A lot of times we have business processes that are quite manual, so it requires many people to uh, to support. But it's really just a very tedious process, something that is very simple to do, but time consuming and takes a lot of resource. And those are the good candidates actually for machine learning, because anything that a simple human cell can do, computers can be trained to do that as well.
Okay, I see that.
That's
This,
the question.
yeah, that's the last question. Uh, okay. Do you have any closing statement, Bagi Cat?
Um, well, thank you very much, folks, for joining our session today. I hope this has been educational and entertaining to most of you. I thank you for spending your time with us. I know that you guys are still in the middle of hackathon, so it's valuable time that you spend with us here. Good luck with your projects and all the best.
Okay. Good luck, guys. Thank you.
Yeah, thank you so much to the Blibli duo for presenting about machine learning and how we can use it to improve the processes. Um, just to now we have a mini story competition in that people can post on their Instagram story how they actually customers doing and I guess add the hack and use the hashtag the by doing that, you'll automatically be entered to a raffle to win $25 gift card